The Pacific Ocean, vast, mysterious, and endlessly captivating. Spanning over 63 million square miles, it is not only the largest ocean on Earth but also deeper and more expansive than all of the planet's land combined. It sits quietly between some of the world's most powerful economies: the United States, Japan, China, Australia. And yet, when you look at flight maps, routes between Los Angeles and Tokyo, or San Francisco and Sydney, something curious stands out. Planes don't fly straight across it. Instead, flights often follow big curves, sometimes going far north over places like Alaska, or dipping south near island chains. At first, this might look strange or even wasteful. Why not just fly straight across the Pacific? So, what's the reason? Is there something dangerous out there? Are airlines avoiding the Pacific because of safety concerns, superstition, or secret rules? The truth is far more fascinating than any fiction. Because this isn't a story about fear. It's about physics, about geometry, about global weather systems, cutting-edge technology, and the incredible precision behind every flight that dares to cross the largest stretch of ocean on Earth. Let's start with a myth that refuses to go away: the idea that planes avoid the Pacific Ocean. In many ways, they do, but not entirely. Every day, a handful of commercial flights do cross its skies. But here's the real mystery: it's not whether planes fly over the Pacific. It's how they do. Some people assume it's all about safety, that aircraft hug coastlines because there's nowhere to land if something goes wrong over the vast, open ocean. And while that concern plays a role, it doesn't tell the whole story. Others believe the Pacific is simply too dangerous, too remote, or even that international laws restrict certain paths. But once you take a closer look, none of that really adds up. To uncover what's actually going on, we need to shift how we think about distance and direction. Because here's the thing: maps lie. Or at least, they distort the truth. A flat map, the kind you've seen on classroom walls and airline screens, makes the world look like a grid. But the Earth is a sphere, and that changes everything. On a globe, the shortest path between 2 points isn't a straight line, it's a curve. It's called a great circle route. And what looks like a strange loop or bend on paper is often the fastest, most efficient way across the Pacific sky. Let's try a quick mental experiment. Picture a globe in your hands. Now stretch a string from San Francisco to Tokyo. You'll notice something surprising. The string doesn't go straight across the ocean. Instead, it curves upward, passing close to Alaska, maybe even near the Arctic. That curve? It's actually the shortest route between the two cities. So those big arcs you see on flight maps, they're not going the long way, they're taking the fastest path. And in aviation, every mile counts. A shorter path means less fuel, fewer emissions, and lower costs. On long international flights, saving even a little makes a big difference. But it's not just about saving time or money, it's about doing it all while keeping safety as the top priority. Now picture this: you're cruising 38,000 feet above the vast, empty Pacific. Just endless blue in every direction. No cities below. No highways. No airports for hundreds, maybe thousands, of miles. Then imagine something goes wrong. Maybe a sudden medical emergency. Or an engine issue. Or a loss of cabin pressure. In moments like that, every second counts. You need to get the plane on the ground, fast. But out here, where do you go? That's where ETOPS comes in. It stands for Extended Range Twin Engine Operational Performance Standards. It might sound complicated, but the idea is simple. It's a set of rules that decides how far a two-engine aircraft is allowed to fly from the nearest emergency landing site. Back in the early days, planes couldn't venture more than 60 minutes away from a diversion airport. That meant hugging coastlines or island chains, just in case. But technology has advanced. Aircraft like the Boeing 787 Dreamliner or Airbus A350 can now fly up to 370 minutes, over 6 hours, from the nearest suitable airport. That's a game changer. It opens up vast stretches of ocean that were once off-limits. Still, safety planners don't take that freedom lightly. Even with that extended range, pilots carefully chart routes that ensure access to backup options, runways in Hawaii, Midway, Alaska, even tiny airstrips on remote islands. In emergencies, every second counts, and every route is designed with contingencies in mind. But the skies aren't just about safety and shortest routes, they're full of constant motion. Invisible forces, like high-altitude winds, are always shifting and changing the way planes fly. And the most powerful of these is the jet stream. Jet streams are fast-moving air currents high above the Earth. They can blow at over 200 miles per hour and usually move from west to east. So if you're flying from Tokyo to Los Angeles, the jet stream can give your plane a helpful push, making the flight faster. But flying the other way, that same wind becomes a strong headwind, slowing the plane down, using more fuel, and putting more strain on the engines. That's why pilots don't always take the same route. They might fly farther north or south to avoid strong winds, or change altitude to find smoother air. And it's not just wind they worry about. The Pacific region is full of natural hazards, like typhoons, tropical storms, and volcanic ash. Pilots and airlines have to plan for all of it, sometimes making adjustments during the flight itself. In short, flight planning isn't just about picking two dots and drawing a line. It's a complex dance, balancing weather, safety, fuel costs, geopolitical restrictions, and the raw laws of physics. And then there's the technology. In decades past, crossing the Pacific meant losing radio contact for hours at a time. Navigation was done with the stars, early satellites, or dead reckoning. But today, real-time satellite communication keeps pilots in constant contact with control centers. Engines transmit performance data mid-flight. Weather systems are modeled with startling accuracy. Planes are smarter, faster, and more connected than ever before. All of that has pushed the boundaries of what's possible and what's practical over the Pacific Ocean. We now see new routes opening, thanks to longer aircraft range, better data, and updated regulations. What was once impossible or risky is now routine. So where does that leave us? Planes don't avoid the Pacific. They navigate it with incredible precision. Those graceful arcs you see on flight trackers aren't errors or overcautious diversions. They're the result of centuries of mathematics, decades of engineering, and hours of careful planning by teams of experts. The next time you're flying across that endless blue expanse and you see your flight path curving across unfamiliar territory, remember, it's not a detour. It's the smartest way to cross the largest ocean on Earth. It's a path shaped by safety, guided by science, and refined by experience. Planes don't fear the Pacific. They master it. And now you know why.